So, let's go. The last person to walk on the moon stepped back inside the lander on December 14th, 1972. We've been staring at it from down here ever since, convinced we know the place. We don't. Every time we've pointed better equipment at it, the moon hands us something that breaks our models. And when humans finally go back, the first landing is now targeting 2028, they're going to find 10 things nobody was fully prepared for. Some of them are wonders. Some of them are going to try to kill you. Number 1, the ice at the bottom of the world. At the south pole of the moon, there are craters that haven't seen sunlight since before animals existed on Earth. The moon barely tilts. Its axis is only 1.5 degrees from straight up, so the sun never quite clears the rims. Never. Not once in 4 billion years. And inside those floors, there is water ice. You step up to the rim and look down. Nothing. Just absolute black. No glint, no crystal field, no fantasy novel sparkle. You can't see it. Your visor reads nothing. It's mixed into the dust, maybe 5 liters of ice per square meter, and you'd need a drill to even confirm it's there. Here's what nobody mentions. We've never actually studied real lunar ice up close. Every sample Apollo brought back was contaminated the moment Earth air touched it. The chemical reactivity is gone. The samples sitting in our labs have been quietly rusting for 50 years. So, when astronauts finally drill into one of these craters, it'll be the first time humans have touched material locked in darkness since before multicellular life. That ice could be a frozen fossil record of the early solar system, volatile molecules, carbon dioxide, methane, argon, trapped since the beginning of things. We don't even know exactly where the water came from. Comets, maybe. Solar wind chemistry. The moon's own interior, exhaling. Possibly all 3. The answer is sitting down there in the dark and nobody has touched it yet. Number 2, the coldest place in the solar system is right here. Those crater floors aren't just dark. They're the coldest natural places we've ever measured anywhere in the known universe. 33 Kelvin, negative 400 degrees Fahrenheit. Pluto is warmer than this. Pluto, 40 times farther from the sun, is at least a degree warmer than the bottom of some craters on our own moon. The reason isn't distance, it's that these craters are perfect thermoses. The rims block sunlight, the floors have no way to receive heat. They just keep radiating warmth out into space forever until they touch the physical floor of how cold matter can get. You can stand at the crater rim in full sunlight, 130 degrees Celsius, and the floor 100 meters below is sitting at negative 200. Same rock, same moon. Any cable you lower toward the bottom physically changes its material properties before it arrives. Lubricants become brittle, metals contract. The thermal shock is enough to destroy equipment built without careful engineering, and inside that cold, preserved like insects. In amber, volatile molecules that would evaporate anywhere warmer. 4 billion years of the solar system's chemical history, frozen and waiting. The moon has been holding on to this since before Earth had an ocean. Number 3, the moon is shrinking and it's been shaking the whole time. As the moon cools, it contracts, the entire body squeezing inward like a grape drawing into a raisin. Over 4.5 billion years, it's shrunk by about 50 meters in circumference. Slow, quiet, continuous. And as it squeezes, the crust buckles. Building cliffs called Lobot scarps, some of them 20 meters tall, as the crust folds over itself. When those fault lines slip, they release moonquakes. The Apollo seismometers logged 12,000 of them over 8 years. Deep ones at 700 kilometers down, pulled by Earth's tidal grip. Shallow ones caused by the shrinking at around 20 kilometers depth. Those shallow ones hit up to 5.5 on the Richter scale, and they last over 10 minutes. On Earth, a 5.5 quake lasts maybe 15 seconds. On the moon, the crust is dry and fractured all the way down, so the energy has nowhere to go. It just bounces around in rings. Your habitat vibrating for longer than a pop song, your equipment shaking without stopping, and the strongest shallow quake ever recorded had its epicenter near the South Pole. Exactly where you're landing. There's more. Researchers ran Apollo 17's old seismic data through machine learning and discovered something quietly unsettling. Every single lunar morning, The abandoned lander that's been sitting on the surface since 1972 starts vibrating. The sun hits it, the metal expands, and it pops. Every 5 to 6 minutes for up to 7 hours. The dead spacecraft has been ringing like a clock for 50 years. We only just found out. Number 4. The dust that destroys everything it touches. After Apollo 17's moonwalks, Harrison Schmitt described what happened back inside the lander as lunar hay fever. Sneezing, congestion, irritation. All 12 people who walked on the moon got it. Missions lasted days. The next landing is planned for a week. Lunar dust is formed by meteorites pulverizing rock for 4 billion years with nothing. No air, no water, no wind to round the edges. Every grain is a microscopic shard of glass. The surface gets bombarded by solar radiation constantly, which charges every grain electrostatically. It clings to everything. Your visor, the seals around your joints, the inside of your gloves. You can't brush it off. The brushing makes it worse because friction increases the charge. NASA's Dust Lab chief described it like this. Imagine smashing a closet full of glass bottles with a sledgehammer and then turning on a leaf blower. That's what you're walking through. By the end of a single EVA, the dust had eaten through Apollo spacesuit boot material and ground through the vacuum seals on sample containers. Every single one. The samples arrived on Earth contaminated. Long term, you're looking at lung scarring. The high silica content, the same stuff that gives miners silicosis, slowly destroys tissue. The moon isn't going to kill you quickly. It's going to kill you the way industry kills people. Gradually, quietly, over time. Electrodynamic shields that use electric fields to repel dust were tested on the lunar surface in 2025 for the first time. They worked, mostly. There's still no complete answer. Number 5. The caves. Right now at the Apollo 11 landing site, there is a pit in the ground, 65 meters wide. And at the bottom of that pit, radar confirmed in 2024, there's a cave. Not a metaphor, an actual cave, at minimum 45 meters wide, up to 80 meters tall, leading into a tunnel of unknown length into the moon's interior. This is what's left of an ancient lava channel from 3 billion years ago. The lava drained, the ceiling held. The void sat empty and unchanged ever since, in perfect vacuum. And this is just the one we've confirmed. More than 300 possible entrances have been spotted from orbit. Some lava tube systems implied by gravity data could be up to 9 kilometers wide. On Earth, lava tubes max out at 30 meters. The moon's lower gravity lets them grow at scales that have no comparison here. You could build a city underground and still have space. Step inside one and the surface chaos disappears. No radiation, no micrometeorites, no temperature swings. The walls are stable, ancient basalt, dark and smooth except where dripping lava froze into formations 3 billion years ago. The temperature holds steady around negative 20 Celsius. It is completely, absolutely silent except your own breathing. These are the most naturally habitable places on the moon, and no human has ever been inside one. Number 6. The moon was erupting while dinosaurs were alive. The official model says the moon went volcanically silent about 1 billion years ago. Cold, dead, finished. Then, in 2024, researchers sifted through 3,000 tiny glass beads from a Chinese lunar sample return and found 3, just 3, that were volcanic in origin. When they dated them, the number came back. 123 million years old. T-Rex was already walking when the moon was erupting. This doesn't mean the moon has active volcanoes today, probably not, but it means the interior held heat far longer than current models allow. There's something warmer down there than we thought. And there are at least 70 regions on the near side that look unnervingly fresh. Too few craters, too sharp, some possibly 50 million years old. Now the honest line, we don't know for certain these are recent eruptions. They might be ancient lava with weird surface physics that makes it look younger than it is. That debate is ongoing, but either way, the moon is refusing to behave like a simple dead rock. NASA is sending a robot to investigate one of these regions in 2028. If it finds genuine recent eruptions, the textbooks get rewritten. Again. Number 7. The swirls nobody can explain. Get a good telescope and find Reiner Gamma on the moon's surface. It's a bright, curling, organic shape, looping across the darker surface for hundreds of kilometers. No hills, no crater, no topography whatsoever. It looks like someone dragged a brush across the moon. First observed in the 1600s, still unexplained. Reiner Gamma is the most famous of dozens of these patterns across the moon, and every single one sits above a pocket of magnetized crust. The moon has no global magnetic field, but these spots do, and that localized magnetism deflects the solar wind, the constant particle bombardment that darkens and weathers the regolith over time. So wherever the magnetic field exists, the surface stays bright. The swirl is the moon's skin protected from aging. But why is the crust magnetized at all? Comet impacts that flash-heated rock. Ancient impactor debris with its own field. Underground lava that cooled slowly in the moon's ancient magnetic field. Electrical currents that ran through the crust billions of years ago. Every theory has real evidence and real problems. No one has ever walked on a lunar swirl, no rover either. The first human to stand on one will be standing inside a mystery that's been visible from Earth for 400 years and remains genuinely, completely unsolved. Number 8, the biggest scar in the solar system. The south pole of the moon sits on the edge of something that resists comprehension. The South Pole Aitken Basin is 2,500 kilometers wide, roughly the distance across the continental United States, and up to 8 kilometers deep. Something about 200 kilometers across hit the moon 4.3 billion years ago, and the evidence suggests it didn't just make a crater, it may have rewritten the moon's entire geology. The asteroid that ended the dinosaurs was 15 kilometers wide. This was 200. The impact likely redistributed radioactive heat-producing elements across the moon's near side. That's why the near side is dark and volcanic, and the far side is bright and ancient. One collision changed the character of an entire world. Under the crater floor, gravity mapping found a hidden mass. Something anomalously dense buried in the mantle, 5 times the size of Hawaii's Big Island, dragging the crater floor downward. The most likely explanation, it's the metallic core of the impactor itself, still sitting inside the moon 4 billion years after the collision. The murder weapon, never removed. You land near the South Pole and you're standing on the rim of this thing. The material under your boots may be rock excavated from hundreds of kilometers deep, brought to the surface by the most violent event in the moon's history. Every sample you pick up is potentially a window into the early solar system. Something no human hands have ever touched. Number 9, the rain you can't see. You step outside and you feel nothing unusual. But the moment you're out there, you're being hit. The moon has no atmosphere and virtually no magnetic field. There's nothing between you and the full output of deep space. Galactic cosmic rays, particles fired at near light speed by stellar explosions thousands of light years away, pass through you constantly. The radiation dose on the lunar surface is 60 microsieverts per hour, 200 times more than standing on Earth, 2.5 times more than aboard the International Space Station. For a short mission, manageable. The Apollo crews absorbed roughly the equivalent of 2 head CT scans over their entire trips. But here's what keeps mission planners awake. Solar particle events. In August of 1972, a massive solar burst erupted between Apollo 16 and 17. If either crew had been on the surface, the radiation dose would likely have been fatal. No warning, no shelter, just deep space physics arriving at full speed. We got lucky. Completely, blindly lucky. For any extended stay on the moon, the solution is underground. 76 centimeters of lunar soil overhead drops the dose to survivable levels. One more reason those lava tubes aren't just interesting geology, they're infrastructure. Number 10, what you'd actually see. You step outside, and the first thing you notice isn't the landscape, it's the sky. Black. Not night black, now you're in full sunlight, but permanent, absolute black. No atmosphere means no scattering, no blue, no haze. Stars visible at noon, the sun hanging in a void. Shadows so sharp they look cut with a blade, and inside them, instant, total darkness. No reflected light fills them in at all. Then you look up. Earth. 4 times larger than the full moon, looks from your backyard. Hanging completely still, swirling blue and white. You can see weather systems if you watch long enough. You can pick out continents. It doesn't rise or set. It just sits there in the same spot in the sky, a fixed living point in all that black. Slowly turning, watching you back. The astronauts who went to the moon and came back were not the same people who left. Frank Borman called Earthrise the most beautiful, heart-catching sight of his life. Edgar Mitchell, on the return flight, felt the boundary between himself and the universe dissolve. These weren't mystical people. These were military test pilots and engineers, people trained to be unimpressed. And every one of them came back changed. You'll stand there on gray dust, under black sky, staring at the only living world you've ever known. Hanging small and bright and impossibly blue in all that nothing. Something will click into place that cannot click from down here. The moon is close enough to feel like somewhere you can go. Far enough that Earth looks like something you could lose. And every generation that gets close enough to look discovers they didn't know either one as well as they thought. 2028. We'll find out what we missed.